Okay. Welcome, everybody. I'm Andrew McNamara. I work at Red Hat. I work on the internal pipeline that we have at Red Hat where we build software. This is Julen.
Welcome, everyone. I work for Red Hat too on Ansible as the CI/CD architect. I'm the user and the contributor for the product or the project that Andrew is working on.
So if you came to Open Source Summit, you might have seen us up here before. We've had the same title, but today the focus is going to be a little bit different. Today, I'm going to talk through the trust model we have, but ultimately how that enables someone like Julen to become a contributor for the pipeline so that you don't only have the people who maintain the pipeline that have the only control over it. So starting off, pipelines really have two purposes. The first is, well, depending on your perspective, the first is to enforce security controls. There's a lot of threats out there on the supply chain, and we need to make sure that the artifacts that go through the pipeline, that come out the end of the pipeline, are protected against as many of those threats as possible. We also need to make sure that we establish organizational trust. You have producers of artifacts that if you then consume it, you need to make sure that the intention of those producers stays the same and is consistent with your knowledge of that trust as a consumer. And ultimately, adherence to that trust, policy compliance to that trust, really should be something critical that a pipeline can provide. But on the other side of that, you can't only have security. You also need to have developer flexibility. You have to be able to have customizable workflows. No two artifacts that are built in a pipeline are really the same. You need to have the ability for people who use that pipeline to innovate and explore new technology, new languages, new artifact types. And if you have ever maintained a pipeline, you know that it's a lot of work. You know that if someone comes to you with a feature request, you can't do everything yourself in how little time the people who are asking want that. And so you need to enable community innovation and collaboration and contributions. And so at Red Hat, we have a project that we built on top of Tekton, which we call Complex. And that is a pipeline that really enables both of these purposes to be served. So how do we go about doing that? Well, it comes down to how we establish trust in the artifacts that we produce. So it's a progressive trust model. We start at the foundation with trusting the platform itself. We have isolated builds. We use Kubernetes. We use Tekton to provide this role-based access control. The different teams that are working have their own namespace isolation. Then you also have the pod and container isolation as well. That's great, but what about the tasks that are run? What about those workloads that are run? We have a set of curated tasks which we trust, and which we know that if you use this task and you have some output of that task, that we know the qualifications of that. And when you build components, we actually have the ability to push out a pipeline for you that you can start with using pipelines as code, where you have all these trusted tasks given to you out of the box. But you have a task. You need to get data between tasks. You need to make sure that data isn't compromised. And so we also have the ability to trust the data that's passed between tasks by having, say, your get clone task, do the get clone, and then upload a tarball of that to the OCI registry, where you have the digest, or it's tamper resistant because the upload is a SHA-SUM of that artifact. And then later, when you're doing the build, you pull that same exact SHA-SUM, and you know that it hasn't been modified between upload and when you pull it down. This also enables builds to be reproducible if you reuse those artifacts, because you know from one execution to the next, if you use that same SHA-SUM, you're using the same data between task runs. That's all well and good, but how do you know what actually was used in producing your artifact? We use Tekton Chains to generate these attestations using the observer pattern. So Tekton Chains runs in a separate namespace. All the user workloads don't have access to the secrets that the Chains uses to generate the signed attestation. And so as an observer, Tekton Chains says, I see this pipeline run with these task runs. Here is the exact remote resolver that you use. Here are the parameter inputs. Here are the parameter outputs. And then it does a cryptographic signature for it. And this Chains with the isolation is how we get to SLSA build level 3 right out of the box. We have all this metadata, we have all this isolation, or we have all this the annotations, but what are we going to do about it? It's great if you just have it and you don't do anything with it, then you're not any better off than if you don't have it at all. And so we have a policy engine that we built as well, Conforma, that can consume the provenance metadata, that knows how to establish trust, that can look to see which tasks are used, what those remote references are used, whether those tasks are trusted or not. Looking at the parameter input, those trust artifacts as well. And ultimately, it can say, this is a good artifact. This passes our policy, or I see that there's some possibility of tampering. You can't do anything with this. It doesn't pass the policy. All right, so we have a way to leverage this metadata, but anybody can just release anything, right? Not quite. There's one final step in this trust model that we have in Conflux. People have, or any of the developers have their own namespace where they can build artifacts, but the keys for getting the software out only exist in a single namespace. So if you want to get your software out, you have to send your request out through a managed namespace, which has the secrets for pushing to these protected registries, and it has its own pipeline that runs. And as a critical part of that pipeline, we run that policy check. So we have the ability to automate this release gating, automate the policy enforcement, and that policy can be customized based on whatever the target for that pipeline is as well. All right, so high-level overview. Hopefully it's not too much, but I'm going to turn it over to Julen now, and he'll describe the process that he went through to try and expand the functionality of Conflux.
Yeah, or say it in other words, how I won this T-shirt that I'm wearing right now. So as I was working on my Conflux adoption journey, I reached to a point where I had a use case where I had to create a container file on the build pipeline itself. On my case, I work on Ansible. This was to build Ansible execution environment where we have our own CLI, where you put a YAML file and you run the CLI, and that's going to give you the full context directory for Builda or whatever tool that you are using. So I said, okay, I cannot do this on Conflux. So I started to work on my sandbox, and thanks to the pipelines as code, my ownership of the build pipeline, as Andrew explained earlier, and the Jira Resolver and Tekton, it was super easy to start working and experimenting on my sandbox until I got a real successful build where, okay, this is working, and I have an execution environment using Ansible Builder. Nice. However, I had a violation that I didn't have earlier. Conflux was complaining that I was tampering the source. And it was right. I was tampering the source. So that's when I went to Andrew and said, okay, how we are going to solve this? It happens that they already had this on the radar, and he gave me basically 3 requirements. The solution must be generic, so anyone on the community can take advantage. It cannot be something Ansible specific, which makes a lot of sense. You need to continue having accurate SBOMs. because you are adding a new task there in the middle, and we need to continue ensuring that the SBOMs are accurate. And for that, there were like two different sub-requirements. One was you need to continue using Hermeto and the build network isolated build, as Adam explained the other day. And the other one was the container that you are using to run that command should be part of the SBOM. So we can know that that was one of the build tools for your process. So with those requirements, I continued working on my sandbox and I made something like what we have on that code block there, changing from my hard-coded Ansible builder calls to something that was much more generic. I enabled a network installation with Hermetic, and I extended the system so I could add the new container image, the script runner image to the SBOM. And at the end, I ended up with a Tekton task where the input parameters looks like something like this. And here, the observer can get a super clear understanding for the attestation, like using the DevTools container and running Ansible Builder Create, and Hermetic is enabled. So I had everything, and it was working on my sandbox. However, it was yet on my sandbox. So my violation about tampering the code continues there. So how you gain trust? You just need to contribute back to the Conflux repos. So they have various repos where we have all the trusted tasks for different purposes. This one went to the build definitions one. I opened the pull request. Adam there gave me super good feedback. At some point, we merged it. And after merging it, I changed my Tekton pipeline to, instead of using the Git resolver from my sandbox, pick up the same task, exactly the same YAML file, but this time using Tekton bundles from the official catalog. Now, my task was trusted. The artifact, the output artifact of that task was trusted. My violation was gone, and the community got a generic way to run a random script before calling to build that. And there you have some examples of how we are leveraging that on Red Hat, on my team or other teams. We are using it to create backstage dynamic plugins for Red Hat Developer Hub. There is people that it's just templating the container file using a make Docker file or whatever. And everyone won from there. And if anyone is curious about those setups, they're on that GitHub repo. All of them are set up, and you can see how they work. So the developer experience for me here, like before Conflux, our pipelines were super rigid. If I wanted something like this, I would need to open a feature request for Andrew's team that it could be leveraged on 5 months or never. I will need to work around meanwhile. I will need to do something. Probably I will commit the container, the context directory, making much more difficult the maintenance of that context directory because I could not use the real tooling that I would want to maintain that container file. After Conflux, I have the flexibility that they need. I can experiment until I reach to something that it's mature enough to go to them and say, hey, I would like to onboard this on our trusted task. And not just me, but the full ecosystem, the full community is gaining a new trusted task that they can use for whatever they need. So that's everything. Thank you, everyone, for coming.